Okay, so let's get started with our variation of stresses with inclination or variation of stresses at a point. We had some discussion last week on this topic. We started it off. I think so we did some derivation. So first of all, I would like to give you a brief introduction, a brief recap of whatever we did previously, and then from there onwards we will pick up and do some additional work. So as I told you that normally what we are doing in this topic is that we are considering a structure which is made up of lots of boxes. Okay, so we take one box and we say that we will analyze that box, or in other words, we try to find out stresses in that box. So essentially, we have got a structure where load is applied and there is a stress flow within the structure. For our convenience, we divide it in different boxes. Okay, randomly we pick up one box and we say that at that box, on each and every side there is some stress. Okay, there are two types of stresses. One is axial stress and another one is shear stress. Therefore, on this box you can see axial and shear stress at each and every face. Please remember that in reality this box is a 3D structure. Okay, it's a 3D box or it's a 3D cube. But in our course we break it down into 2D. Okay, or we simplify it into a 2D structure or 2D box and we analyze this one. 3D is for a more advanced classes. But please keep this thing in mind that actually in reality it is a 3D box. Now in this box we have x-axis and y-axis defined. Okay, and what we are trying to do is that we are trying to see what will happen if we change the inclination of this box. What will happen to these stresses? Okay, so we have got this box which is over here. Okay, and at each and every face we have stresses appearing. Now I say that, now remember that this is taken from one structure which is like this. Okay, but there can be different boxes. Okay, so this is like a chain of boxes. So within a structure you can have boxes like this, but at the same time you can have boxes like this also. So if I, in other words, if I cut this section over here, so I can have another box which goes like this. So lots of chain of boxes which continue from that plane. So in other words, what I'm saying is that I've got this box, I take one particular inclination. Okay, so this is also, there is going to be another box which is like this. Okay, and this box will have then axial shear at this face, and similarly it will have axial shear at this face and all the faces. Okay, so what is shown here is just horizontal and vertical boxes, but you can also have boxes in any inclination. Yeah, our idea, our point of making of looking into this topic is, our objective is that we want to see which of these boxes will give you maximum stress. Okay, because maximum stress is something we are after. Why? Because if you know the maximum stress which is running into your structure, then you can assign an appropriate material to it. You can assign appropriate geometry to it. Everything is related to stress. To stress, isn't it? Stress is equal to my or ei. Okay, my or I. So you have got applied moment, and then you have got moment of inertia, which is I. Okay, and I is geometry. but at the same time stress is equal to E times strain. So E is the material property. So you have to see what should be the geometry of this and what should be the what would be the appropriate material to take that type of loading. You understand my point? So stress is an important variable which we are trying to find out. So, but stresses, as I told you, they can be at any inclination. Okay, so they can be like this, or you can have like this. So therefore, we what we do is we divide the whole structure into boxes, and then we say that these boxes we can orient, okay, and find out another boxes. These actually we divide the structure into boxes, and we assume that it is made up of chain of boxes. Okay, and out of that chain we want to find out which is the box which will give us maximum stress, or which is the face which will give us maximum stress. That is what our aim is. So that's what is done over here. We have, as I said, stresses which are on the faces. And these stress, we are trying to find out a stress at particular inclination. We discussed that we can use equilibrium equations to derive these stresses. We have got two types of stresses. One is axial stress, another one is shear stress. So you take summation of all the forces in those two directions, perpendicular and parallel to the face, and you get these two equations. Okay, so let's name them. Let's call them equation 1 and equation 2. Now once we have these two equations, okay, what we can do is we can maximize. Now this is just a general equation of a stress. So of a stress at a particular inclination. So you can have this theta varying in any direction. Yeah, so this theta can be in any direction. What we are interested in is finding out that theta which will give us maximum stress. Okay, so that means we have to maximize this equation. That means we differentiate that with respect to theta, equate it to 0, and find out our theta. Okay, and that's what has been done. So this is from 1. Okay, and let's call it 3, and this is from 2, and let's call it 4. Okay, so these are the two equations which we get from differentiating, okay, and then equating it to 0, maximizing it in other words. So you got the rotations theta. Now once you have them, you plug it back in the same 1 and 2 equations, okay, and you get these two. But please remember that this is these are trigonometric functions, and these are trigonometric variables, and these have actually periods. Period means like you have they change their values. Okay, so for example, at different inclination. So in other words, you can have same value at two periods, okay, or at two inclinations, or many inclinations, you can have same values. Why? Because these are harmonic functions, and they give you same equations, same values. So this is from tangent theta we know that its period is 0 and 90. Tangent 0 is 0, and tangent 90 is again 0. Okay, so you have that, but in order to plug it in this value, you will have to have, this is 2 theta. So in other words, you make it, this is 2 times theta, so it's 0 this equation has got two periods, one is 0 and one is 180. It's not 90. So these two equations, so this equation you will get at 0 degree and then after that at 180 degree. And similarly this one you get at 0 degree and then at 180 degree. But this theta, that is at 0 and 90. Okay, all got to do with the period of tangent theta. So one is for theta, another one is for axial stress, the second one is for the shear stress. Once you find these two out, you can plug them back into these equations and you get this equation. Okay, you get this equation from putting this value of 2 theta into this one. So stress 1 is plus and stress 2 is minus. So let's call it 5. So this is equation 5, okay, which you get from plugging value of 2 theta into 1, okay. So, and then you have, let's call, if you plug the equation 4 in 2, you get equation 6. So that is your tau max. So these are the two equations which we get. Now, once we get that, you can see that tau max, what is tau max? Tau max is also equal to if you add from 5 and 6, okay, you can see that tau max is also equal to stress 1 minus stress 2 divided by 2. How can we see that? Stress 1 is plus, stress 2 is minus. You add those two, what will happen? This thing will cancel. Okay, so from that we can say that tau max is plus minus stress 1 minus stress 2 divided by 2. So if you take this stress 1, stress 1 is stress x plus stress y divided by 2 plus this, and stress 2 is stress x plus stress y divided by 2 minus this. If I do stress 1 minus stress 2 divided by 2 on it, I will get exactly this one. You can see that. Okay, stress 1 is this one, stress 2 is that is the negative one. If I take stress 1 minus stress 2, what will I get? I will get this will cancel out and I will get 2 times this thing. And when I divide it by 2 then, I will get tau max value, which is that. So that is derived from this equation, okay, keeping in view equation 6, this one. So this comes out to be 7. Okay, and this makes sense also. You see, shear is actually the difference between stresses. Shear is a difference between stresses, and we discussed it when we were doing shear, that if you have got a structure, there is one stress in this direction, if I have got a structure, one stress is in this direction, another stress is in this direction. What is shear? Shear is the difference between the two. Okay, and that's what this is saying, that the shear is actually nothing but it's a difference between two stresses. Okay, so that is an important consideration. Okay, now after this, as I told you, that now what you can do is you can take you have got this face which is at an angle theta from this vertical face. Okay, and I told you that this is like chain of boxes. If you take a particular face at some angle, you assume that there is a series of boxes then stacked together in that lane. So we are assuming that if I take, this is actually part, this is a face of another box. Okay, so if I take this another box which looks like this, what will be this angle? This is theta. What will be this angle for this one? This is 90 degree. So if I have got this side, if I have got this box which is, and I say that what is the inclination, if I want to find out stress for this member, this face, how can I find it out? Remember, this is this one, and I want to find it out for this one. I take again stress n and tau n, put the value theta plus 90 degree in them. Okay, theta plus 90. Why? Because it's very straightforward. Look, this is theta, this face is a theta. Theta, I want to find out stress for this one. That is what? Theta plus 90 degree. So I just put values of theta plus 90 degree in these two equations. Okay, so when I put that, so this is okay, theta plus 90 degree there. So this is cos 2 theta plus 90 degree. You open that identity and you get minus cos 2. And this tau yx becomes positive. Okay, so this is just your opening identity. Cos alpha plus beta. Okay, that identity has been used. And similarly, you put theta plus 90 degree into, you get this one. So this is 7, 8, and 9. Okay, so that's what we have. Okay. Another thing to check, to see is that if you add this stress 1 and this stress 2, remembering that this is actually the maximum stresses. Okay, if you add them, you get stress x plus stress y divided by 2. So you get stress x plus stress y, isn't it? When you add them, when you add these both, you get stress x plus stress y. Why? Because this one cancels out. As I told you that stress 1 is having plus this bracket and stress 2 is having minus this one. The tau's get cancelled out, you get stress x plus stress y. So addition of any two stresses, okay, remains constant at particular plane. Addition, when you add them, yes, stress x and stress y, when you add the two stresses in two directions, okay, that will be, if I take stress y and stress x, okay, add them, and the stress, axial stress which is there, yeah, that axial stress, stress 1 and stress 2, for that one, that both remains constant. So in other words, what I am saying is, remember, there is one stress 1 and another one is stress 2. So again, there is a box like this. This box has got stress 1, okay, and there is a stress 2 in this direction. So stress 1 plus stress 2, that the summation of those two stresses for that box which is at inclination, and summation of the axial stresses for this box, which is, they both are the same. Can you see that? Yes, so that is another thing. Now, do you have any question? Any question in this one? So another thing is that these two angles, okay, 2 theta and 2 theta s. If you multiply them, okay, this is like a slope, isn't it? And you multiply them, you get -1, isn't it? So that means that the maximum axial stress, is, and or the plane which has got the maximum axial stress is perpendicular to the plane which has got maximum shear. This theta and this theta, if I multiply, yeah, what do I get? I get -1. When you multiply two slopes and you get -1, that means they are perpendicular. Remembering that this theta you have got from maximizing this one and equating that to 0, and this theta s you have got maximizing 2 and equating it to 0. When I say maximize, that means differentiating it with respect to theta and equating that to 0. Okay? So these two planes are perpendicular to each other. Okay? So that is an important consideration. Okay? So that's all we can take from this. Now, what we say is that if I take stress N, okay, now let us do some algebraic manipulation. Okay, so and what do we mean by that? I take this to this side. Yes, so I take from 1 I write stress N minus okay, from what I have done is I have taken this to that side. Yes, and then I square both sides. I take squares of both sides. I do some trigonometric okay, so I square them and add them, and what I get is that's what I get. Okay, so what I've done is I've got this equation. Yeah, I have taken this to that side, I have squared them and squared both sides. So this is then a minus b whole square, and this is again a minus b whole square. So I do the a square plus b square plus 2ab thing and then do some addition and using algebra. Okay, I get stress minus stress x plus stress y divided by 2 whole square plus tau square is equal to stress x minus stress y whole square plus tau y x square. Okay, that's what I get. Okay, you can put stress n, call it stress n and tau n. So this is from 1 you get this square and then you, in light of 2, so let me okay, so squaring, adding, and then using this one, you get this equation. Now, what is this? What is this the equation of? This is the equation of circle. Okay, stress minus, so you can write this is the equation of circle. Stress minus C, this is my C. Tau minus 0, the second ordinate has got 0, is located at 0. And R square, so this is my R square. So we can put this in, so the variables, okay, in this in case of this circle are stress and tau. Stress and tau, these are the variables. Okay, and so we have to draw our circle in the stress and tau axis. Because on the stress axis it is offset, because I've got C over here. Yeah? So I have offset my circle at C, which is stress x plus stress y divided by 2. Okay, you can see that this is at a distance stress x plus stress y divided by 2, center C. And it is not offset, it's at 0 for the second variable, so that's why my circle is exactly on the second, on tau is equal to 0. Okay, so my circle is on tau is equal to 0 and stress is equal to stress x plus stress y divided by 2. Agreed? Now, this is my radius. Stress x minus stress y divided by 2 whole square plus tau y x whole square. So that is my radius. I can draw my radius based on that. So once I get the center, okay, and once I get the radius, I can easily draw this circle. Okay? Please remember, I know the stresses on this face. So, in order to find out my centroid, what I have to do is, for that circle, I have to add stress x with stress y, divide that by 2, I get the centroid. And then do stress x minus stress y divided by 2 whole square plus tau yx whole square, okay, square root, that gives me the radius. So I know the center, I know the radius, I can draw this circle. Now in this circle, I've got one point, okay, which is A, and that I call x-axis. So the stress which is over here on the x-axis, okay, I can draw it at this point. Stress yy and tau over here. Yeah? This is our circle, and all the stresses are on this circle. Okay?